Good morning, friends. I am S. HARIHARAN, Head PG Department of Mathematics, KSR College of Arts and Science for Women, Tirunelveli. In this video, we are going to discuss about graph theory. It means what is meant by graph theory, what are the importance of graph theory, and so on. Let us see one by one. So applications of graph theory. Graph theory, it works in computer networks, distinguish between two chemical compounds with the same molecular formula but different structures, solve shortest path problem between cities, scheduling exams and assign channels to television stations. Next one, in this video we are going to cover important topics like definitions of graph theory, types of graph, degree of a graph, first theorem of graph theory and subgraph. Let us see one by one. Definition. What is meant by graph? A graph G consists of a pair where V of G is a non-empty finite set whose elements are called points or vertices, and E of G is a set of unordered pair of distinct elements of V of G. The elements of E of G are called line or edges of the graph. Loop. A loop is an edge whose endpoints are equal. That is, an edge joining a vertex to itself is called a loop, represented as u, u equal to u. And multiple edges, it means edges joining the same vertices are called multiple edges. Simple graph consists of V, that is a vertices, a non-empty set of vertices, and E, a set of unordered pair of distinct elements of V called edges, and it is called simple graph. It means there is no loop. That type of graphs are called simple graph. Next, multigraph. If more than one edge joining two vertices are allowed, the resulting graph is called a multigraph, and this is the example. Next one, pseudograph. So we know very well edges joining the same vertices are called multiple edges. If further loops are also allowed in that graph, the resultant graph is called pseudograph. Next one, U and V. Two vertices U and V are said to be adjacent when we will say these two vertices are adjacent. That is, if U, V is an edge joining U to V and E is called incident with U and V. U and V are called endpoints of the edge U, V. Then degree of a vertex. It means the number of edges incident on a particular vertex. A loop contributes twice to the degree. Next one, pendant vertex. In a graph, any vertex, the degree is equal to 1. That vertex is called pendant vertex. Next one, isolated vertex. In a graph G, any vertex, the degree is equal to 0. That vertex is called isolated vertex. Next, it is the first theorem of graph theory. That is, the sum of the degrees of the vertices of a graph G is twice the number of edges. That is, 2E equal to summation degree of V. Next definition, complete graph. It is represented by the symbol Kn, and it is the simple graph that contains exactly one edge between each pair of distinct vertices, and the following are the examples of complete graph. K1, K2, K3, K4. It means complete graph with one vertex, complete graph with two vertices, complete graph with three vertices, and complete graph with 4 vertices. Next one, cycle. It represented by the denoted by the symbol Cn, and n it should be greater than or equal to 3. Consists of n vertices v1, v2, etc. vn, and edges e1, e2, etc. and so on. And here, this is the example C3. It is a circle, and C4 it is also a circle. It means C3 cycle with 3 vertices and C4 cycle with 4 vertices. Next one, next definition, wheels. It represented by the symbol Wn, obtained by adding additional vertex to Cn and connecting all vertices to this new vertex by new edge. And the following are the examples W3 and W4. Next, bipartite graph. In a simple graph G, if the vertex set V can be partitioned into two disjoint sets V1 and V2 such that every edge in the graph connect a vertex in V1 and a vertex V2. And complete bipartite graph, it represented by the symbol K, M, N, is the graph that has its vertex set partitioned into two subsets of M and N vertices respectively. There is an edge between two vertices if and only if one vertex is in the first subset and the other vertex is in the second subset. Next one, subgraph. Let H be a graph with a vertex at V of H and edges at E of H, and similarly let G be a graph with vertex at V of G and edges at E of G. Then we say that H is a subgraph of G if V of H is a subset of V of G and E of H is a subset of E of G. And these are the following examples of subgraph: G, U, that is G, H1 and H2. Thank you.